If you're already comfortable making a spreadsheet that looks like this, with color-coded headings, columns full of numbers, filled nicely down, and graphs, XY scatter plots made by yourself, where you can fix the title, the numbers of the axes, you're ready to start computational physics and programming. See this delta t? We're going to make this delta t do what we cannot do by hand or do not want to do by hand. We're going to make a special data box for delta t that will fill the time for us. Make a special data box here so that you'll know just by looking at it that this is really important programming data. Make two while you're at it, and make room for the numbers so you can see them when you find them. This data box will be delta t. See the symbol in here? Insert a symbol. You should have access to all the Greek letters you need, so you don't need to drag and drop triangles. Here's the delta. And this can be delta t as measured in seconds. And it will be equal to a number that is the difference between these 2 points. This is a delta t of 1. We go 1, 2, 3, 4, 5. We had 6 data points, and the curve was floppy. Let's set a delta t that's small, but not too small. Maybe 0.1, maybe 0.01. Now, instead of having to type in these numbers by hand, we're going to make time a formula. Equals, this is a formula. The one up here, the previous one, plus, careful where you click, don't click on anything unless you mean it, this one. It's always 0.01, and it's always going to be found here in column F. So make sure you've got $2 signs for your absolute cell reference. Now, fill down. Drag this as far down as you want to go, and Control V for fill down. Hey, we've got data for lots and lots of times. It's not just 0 and 1, it's everything in between. All right, drag down and fill down as far as you have patience to go. It'll only be a few seconds. Now we're at 5 seconds. Now we're, okay, 6 seconds. Looks good enough. There we are at 6 seconds, and now we've got data. We're going to do the same thing for G. The acceleration here is not going to change, but in air-resistant situations it will. So let's make sure that we know what G is supposed to be. G is a positive number. It is the strength of the gravitational field. It is 9.81. Positive 9.81. Wait a minute. Acceleration is a vector. Acceleration has a direction. Acceleration goes down. Acceleration is negative. Careful where you click. Don't forget the equal sign. Click very carefully. Don't click anywhere else. G2. Proofread. It's always going to be 2. It's always going to be G. That's where we're storing G. Now, similarly, I don't have to type in 9.81 a bazillion times. I can just drag and fill to the end of my data set, select all the way down. Excel will figure out that you mean it sooner or later. Here we are, Control D, fill down, and there are all those 9.81. Now for velocity. Our initial velocity is 5 meters per second. That's special. In fact, it's so special I'm considering putting it in a special cell over here all on its own. Let's take the slow way out. We'll leave it here. The initial velocity is 5. Why? Because we said so. Start, therefore, in the second cell. Equals, you have a formula. Initial velocity, whatever it was before. I started at 5 meters per second, but go up one cell and over. Keep everything in line 2. When I was going at 5 meters per second, I had an acceleration of negative 9.81 times, here we go, delta t. Take it seriously. Delta t is over here. For the 0.01 seconds, it's very small, just for 10 milliseconds, when I was going at 5 5 meters per second, I was accelerating downwards and losing 9.81 meters per second every second. And this is always delta t. It's always here. It's always here. Make sure there are $2 signs. Don't click anywhere else. Press enter. There. That's how fast I'm going. Now we'll try it again for the height. Equals. This is where I was before, but I went a little bit further up. How much further up? Well, I was, again, back in line 2. Just for that 10 millisecond period, I was going at 5 meters per second times delta t. Absolute cell reference. Absolute cell reference. But I did lose a little bit of height because I wasn't rocketing up at 5 meters per second the whole time. I was losing speed. Plus 1/2 times acceleration. Here we are. There's the acceleration. It was negative 9.81. For how long? Delta t squared. Careful where you click. Careful with your arrow keys. Notice when I tried to arrow key back, it just entered the formula. So I have to go in and click here very carefully. There's my delta t. Now, hope the dickens that they're right. I didn't see any typos. I don't see any typos. So I'm going to take these and I'm going to fill them all the way down. Columns B and C. All right, it'll take a second to drag, but isn't this nicer than filling in thousands and thousands of data points? Fill it all the way down to the bottom of your data. If you have an old graph for all of columns A, B, C, and D, these numbers will immediately appear on your old graph. If you're starting here and making a new graph, I will show you how to put this data on the new graph. Like we said in the previous video, if you want to start from scratch and make a new graph, you can select the 2 columns you want and insert an XY scatter plot. Now the dots are not going to be in our way and we don't need to smooth it over with a line. However, then you'll have to set your axes by hand, your tick marks by hand. You'll have to do all the labels by hand. So there is a certain amount of time saved in using an old graph. Why isn't our old graph working? Well, let's select the data. Freefall, height, that's exactly what we want. Well, edit, freefall, B1, yes indeed. Freefall, A1 through A7. Oh, the reason it looks so squished is that we only had 6 data points here, 2 through 7. I don't want to stop at 7. You can either type the number in by hand, if you remember where it was, or you can get rid of that cell reference entirely. You can go here, you can click and say, I want all of column B. Notice if you're going to click anything, you have to clear it first. I want all of column B. Don't click anywhere else. Press enter. There we go. And there's our graph with the rest of our data. So we're going to go through here again. Select data. Why do we have 2 velocities? We don't need 2 velocities. We just need 1. I'm going to edit this. Make sure we've got the full column here and the full column here. Watch out, that's C. That's funny, that graph doesn't look right. We could also just take away this, go to the chart data range, and say I want everything from A to C. That's fine. Take off the height, or remove the height. There we go. That looks like what we want. Fix your acceleration graph by whatever method you like best. Select your data, and one way or another, make sure that you have all the data, not just the 1 through 7. Make sure it looks right. You know what constant acceleration looks like. You know what velocity under constant acceleration should look like. And you know that parabolic motion that starts, goes up, and comes all the way down. With these 3 freefall graphs looking exactly as they are supposed to look, and some practice here doing some official data cells, you are now ready to see what air drag does. using the computer to do what algebra is not going to do for you.